Hi everyone. So we are going to learn a very important topic and the very first topic in physics. So that is units and dimensions of class 6 techno syllabus. So before going to learn what is units and dimensions, let us learn what is physics. Physics is the study of nature and its laws. So anything happens in our universe, it happens due to some phenomena and it follows some rules. So revealing that rules is nothing but physics. For example, I am able to hold this piece of chalk because of one property between my fingers and this piece of chalk, the surface of the piece of chalk. That is called friction. So without the friction, I cannot hold this piece of chalk. So if I observe this and if I question it and if I inquire about it, then I will get one concept. That is only the concepts of physics. In the same manner, everything, whatever happens in the universe, so many phenomena happen because of some rules. Behind every phenomena, there are some rules. Revealing that rules is the duty of physics. So even we observe so many things on our nature. If you are able to reveal the rules behind it, then that will be a concept of physics in our subjects. So before going to learn physics in depth and in a clear manner, we have to understand the basics of physics. The very first lesson of physics is units and dimensions. Before learning to learn that, first we should have a clarity of quantity. What do you mean by a quantity? Quantity means it's nothing but a size or the amount or the vastness or the magnitude. Simply, it is the answer for question how many or how much. For example, how many pieces of chalk are there in my hand? 2 pieces of chalk. That is the answer for this quantity, that question. So that 2 is nothing but the quantity. How many liters of milk is there in that bottle? 2 liters, 3 liters, 4 liters. That answer is nothing but the quantity. How much happy you are if you get the first rank in IIT? I will be very happy. We will be saying that answer is also a quantity. Very happy, so much, many, like that. So the size or amount or the vastness or the magnitude comes under the quantity, or simply it is the answer for the questions how much or how many. Let me write that on the board. How much or how many. How many students are there in the classroom? You will get the answer. The answer nothing but quantity. How much amount of sand is piled up over there? You will say some answer. That is nothing but the answer for how much. It is also called as quantity. How much happy you are if you get whatever the desired things you get it, right? So you will be saying some answer, very much, very bad, very sad, like. So that is also answer for quantity. So from this we understand that few quantities are measurable and few quantities cannot be measured. For example, piece of chalk, I can measure, I can count 1 and 2 and I can say the answer. So this is nothing but a measurable quantity. I am very happy. Can you measure the happiness? I am very sad. Can you measure the sadness? No. So there are no measures to measure the happiness and sadness. So that's why physics does not deal with the quantities which are not measurable. So that is the reason our focus is on physical quantity. So let us discuss what is physical quantity. Physical quantity. So simply, as I told, the physical quantity is nothing but a quantity which can be measured. For example, can you measure the length of this piece of chalk? Yes, I can measure with the help of a scale. Right? Can you measure the weight of this mobile? Yes, I can measure. So this length, mass, and I can measure the area of this desk, this table surface, and I can measure the weight of this one. I can measure the volume of this duster. So like that, length, mass, volume, density, force, work, energy, these are all the measurable quantities. So all those quantities will come under physical quantity. Let me write the definition on the board. A quantity which can be measured. It is nothing but a quantity which can be measured. Example, length, mass, and even we can measure time also, like that, so on, etc. So whatever the topics we have discussed so far, let me revise that. So we are going to learn the very important topics of physics. Physics is nothing but the study of nature and its laws, and then we learned about quantity. Quantity is nothing but the size, amount, magnitude or the vastness of the objects, and simply the answer for how much or how many. And then we studied physical quantity, then a quantity which can be measured, example length, mass, time. But there are so many physical quantities which we are going to deal with in physics. These physical quantities can be organized in several ways in several systems of physical quantities, several systems of physical quantities. So found in that, I want to explain you few physical quantities and the very important systems. For example, earlier 1874, we were having a system called Fps system, where length, mass and time are organized in 3 different units. This is a foot and a pound and a second in 1800, earlier to 1870. That is, look at this, foot, next a pound and then second in this system. So better to write this in small letters, pound and then second. And after that 1874, scientists have used this system which is called CGS, given by British Association of Advancement of Sciences, and this is used centimeter. Next, the mass is made in grams, okay, and the time is measured again in a second. Next, afterward we have gone to the metric system of units, which is called Mks system, in which we measure the length in terms of meters, meter. Next, it is in kilogram, mass is in kilogram, and then time as usual in second. But this is earlier to 1874, and this is around 1874 onwards. Then it is in the years 1889 onwards. Then after having these many awareness, means these many organizations of the systems of units, scientists faced some difficulty in organizing these units. They were unable to create the relationships, draw the relationship between these CGS units and Mks units. That is the reason 1960 later all the scientists are together and they have prepared one system of international units, which we are, even nowadays we are using this system, SI, system of units. In this, actually earlier system, the Fps, CGS, Mks, they have organized these quantities only. For example, length and pound, gram, kilogram for the mass, organization of the physical quantity mass, and second it is for time. So if you compare, if you just observe carefully, time is organized in all the system with second only, but pound, mass, pound, gram and a kilogram like that, and then length, foot, centimeter and meter like that. But later on the scientists were in need of so many multiples and submultiples, means a smaller units and the bigger units, to study very large quantities and the small quantities. That is the reason the scientists sat together. 1960 onwards we started using this SI system of units, system of international units. In this we have 7 physical quantities. So it is very easy to remember. I will give a mnemonic to understand this. So L, M, T, S, T, A, L. Please remember this. If you are able to see this, letters, first letters L, M, T, S, T, A, L, you are able to see the 7 letters. The 7 letters represent 7 physical quantities. Let me write those. For example, first one is length, as usual in the earlier systems of units. Next, this is M for mass, and T for time, S for, this is a new one compared to these three systems, and strength of electric current, and next T for thermodynamic temperature, and next A for amount of substance, and next, last but not least, luminous intensity. Okay, these are the 7 fundamental physical quantities which are measured in a system of international units. So earlier we used Fps and then CGS, Mks, and the latest development is system of international units. Even now, even today, the scientists are using these fundamental physical quantities only. But before going to these various systems of units, and let us organize the physical quantities into different types. Generally, the physical quantities are of 3 types: fundamental physical quantities, derived physical quantities, and supplementary physical quantities. So whatever I mentioned in the essay, the list L, M, P, S, T, A, L, these are all fundamental physical quantities. These are also called as fundamental physical quantities. Fundamental physical quantities in SI system of units. So let us learn clearly about the derived physical quantities and supplementary physical quantities in detail. So let me explain once again. The fundamental physical quantity system of international units are length, mass, time, strength of electric current, thermodynamic temperature, amount of substance, and luminous intensity. So in the first 3 categories of systems of units, length, mass, and time are organized in this manner, and nowadays the scientists are using this length, mass, time, and strength of electric current, thermodynamic temperature, amount of substance, and luminous intensity in different manners, and these are also having some units. Before going to learn that, we have to learn about derived physical quantities. So let us learn about derived physical quantities in SI. Okay, so before that, let me write the physical quantity flow chart. Physical quantity, and this physical quantity is organized in 3 ways in a system of units. The first one is fundamental, the next one is derived, third one is supplementary. So this is the organization of physical quantities: fundamental physical quantities, derived physical quantities, and supplementary physical quantities. So as we learned earlier, these fundamental physical quantities are length, mass, time, strength of electric current, thermodynamic temperature, amount of substance, and luminous intensity for your recalling purpose. And then let us go for derived physical quantities. So these are the physical quantities which will be derived from these fundamental physical quantities. So these are nothing but alphabets of English. Generally, whenever we are going to learn English, we have to learn first alphabets, then we have to go for words which are formed by those alphabets. Even in physics, these fundamental physical quantities are nothing but the alphabets of physics. If you just compare those, if you organize those, then you will be getting the derived physical quantity. For example, I want to find out the area of this desk. This desk, the surface of this table is in the shape of rectangle. So what is the area of the rectangle? Length into breadth. So first I have to measure the length of this desk, and then breadth of this one, I have to multiply this. So simply area. If you expand this, what do you get here? Length into breadth. So it's nothing but length, and breadth is also kind of length, and the length into length, it's nothing but length square. So by multiplying this length 2 times, we are getting the area. In the same way, volume. Here you will be getting length into length into length. It's nothing but length cube. So here we can say that this area is a derived physical quantity from this fundamental physical quantity. In the same manner, volume is also a derived physical quantity from these sets of fundamental physical quantities. In the same manner, density is also a derived physical quantity. Density is nothing but mass by volume. Here mass is fundamental physical quantity only, and the volume is the multiplication of length for 3 times. So this density is derived from mass and length. So length and mass are the part of fundamental physical quantities, and this density is coming under derived physical quantity. So like that, so there are so many derived physical quantities which we are going to learn in future in physics. Then what is supplementary physical quantities? There are 2 supplementary physical quantities in SI. First one is plane angle. The second one, solid angle. So this is the total organization of physical quantity. Fundamental physical quantities, there are 7 fundamental physical quantities in SI. Then derived physical quantities, there is no limit for this number. So whatever the other things, what are the other physical quantities which we derive from fundamental physical quantities are coming under derived physical quantity. So many are there. So supplementary physical quantities are 2 in SI system of units, that is plane angle and the solid angle. So this is the organization of physical quantities in different systems of units, and the organization of means these are types of different physical quantities. One is fundamental physical quantities, derived physical quantities, and the supplementary physical quantities. This is our first concept. So let us try to answer few questions which are given in our exercises. A measurable quantity is taken as. So a measurable quantity. So earlier we have started learning with quantity, and then we derived physical quantity. Then what do you mean by the physical quantity? Physical quantity is nothing but a measurable quantity. The options given are physical quantity, fundamental quantity, and derived quantity and supplementary quantity. The option obviously physical quantity. So let me write one question on the board and solve this. This is a question. Temperature, and the second option is given as density. The third point is given as solid angle. So this is nothing but a matrix matching type. The A, B and C. First one is supplementary physical quantity. Supplementary, let me write the shortcut over there. Next, fundamental physical quantity. Next, obviously derived physical quantity. So let me have the example. Temperature. So I have given a mnemonic to identify that fundamental physical quantity, LMTST. That T is nothing but thermodynamic temperature. It is also called as temperature, and this is obviously coming under which physical quantity? So fundamental physical quantity. Obviously the option is B. Next, density. So already derived in the just earlier only. Density is nothing but the division of mass by volume, and then we have come to know that the density is derived from mass and length, so it is nothing but the density which is coming under the option C. Next, solid angle, it is a special case. 2 special physical quantities are there in SA. Those are supplementary physical quantities. One is plane angle, next one is solid angle. Obviously here the answer will be A. So once again let me explain. Temperature comes under fundamental physical quantity, that is the reason option B. Density comes under derived physical quantities, because it is derived from the fundamental physical quantities. That's the reason it is C. And then solid angle, then the option will be going for supplementary physical quantity. So last and important concept of this is the set of fundamental physical quantities. So what do you mean by set of fundamental physical quantities? We have learned fundamental physical quantities, but this is different. Set of fundamental physical quantities. Okay, so here let me take one set here. So length, mass and force. This is the first example. Let me look at this. So length, mass and force. So here length cannot be derived from mass and force. If we take in force and mass, we cannot derive length directly. So if you take mass, mass cannot be derived from length and force directly, and the force cannot be derived from length and mass directly. When you take these kind of sets of physical quantities, and no need, there is no rule that in set of fundamental quantities, in the heading I have written that fundamental physical quantities, but I have taken length, mass, fundamental physical quantities only, and here I have not taken the fundamental physical quantity. Force is the derived physical quantity, mass into acceleration. But if you take under a set, if no one is derived from the remaining physical quantities in the set, then it comes under set of fundamental physical quantities. So let me give one more example for this. Length, velocity, mass. Here also, the length cannot be derived from the remaining two physical quantities. Velocity cannot be derived from length and mass. Mass cannot be derived from velocity and length alone, because in order to need mass, we need volume and density also, right? So this is a fundamental physical quantity, we know it derives, and velocity will be derived from length by time. So there is no time in this set. That's the reason this first set, length, mass, force, is called a set of fundamental physical quantity. And next, length, velocity, mass is also a set which is coming under fundamental set of fundamental physical quantities. Let me give which is not a set of fundamental physical quantities. I'll just change this: length, velocity and time. Look at this. Length is a fundamental physical quantity, time is also a fundamental physical quantity, and it is a derived physical quantity. Let us see how this velocity is derived. Velocity is nothing but displacement by time, and means length by time. So here length is available and time is available in that particular set. So this set comes under set of, it doesn't come under set of fundamental physical quantities, because here the velocity can be derived from these two. That's the reason this we do not take it as a set of fundamental physical quantities. Please be careful. I'll tell the definition once again. If no physical quantity is derived from the remaining physical quantities in a particular set, then the set of fundamental physical quantity will be existing. So here, the first two are the examples for set of fundamental physical quantities, and the third one I have given the clear example which is not a fundamental set of fundamental physical quantity. So here length, velocity, time are given. Here velocity can be derived from length and time. That is the reason I cannot take this as a set of fundamental physical quantities. I hope you have understood this concept very well. Thank you very much.